Hey all you cool cats and kittens, welcome back to another round of Science AMI. So you should have already watched a couple of videos that talk about momentum and collision and impulse. So I'm going to do a little lab today, but first we're going to go over the formula for momentum. So remember, P equals momentum. I think the guy in the video made a joke. He was like, I really don't know why, but P means momentum. So P equals momentum, M equals mass, and V equals velocity. So the formula for momentum is mass times velocity. So how heavy something is times how fast it's moving tells you its momentum. So due to the law of conservation of momentum, whatever the beginning momentum is, that also has to be the final momentum or the ending momentum. So I'm going to go out in the hallway, and I've got a special guest here today that's going to help me, and we're going to show you how the law of conservation of momentum actually works. So that'll be the next video. So I'll see you guys in just... All right guys, welcome back. So this is my special guest. This is my youngest son, Rhett, and he's going to help me demonstrate the law of conservation of momentum for you guys. So we're both going to start right here. We're going to start Rhett's chair at the 0 mark, or as close to it as we can. And Rhett and I are going to push off of each other. Well, you know, because momentum equals mass times velocity, since we're both sitting still and not moving to start with, our overall momentum is 0. So due to the law of conservation of momentum, our final velocity, or our final momentum, should be 0. But because Rhett has a much smaller mass, he should move back a lot further than I do. So we're going to check it out and see how it goes. And we're going to get a final displacement on Rhett so that we can calculate his velocity. All right, Rhett, you ready? Okay, keep your chair at 0. Miss Smith, let us know. Give me your hand so I don't push you off. Give me that hand. Okay, is he close to the 0?
He needs to go a little bit towards himself. Yep, that's better. Yep.
All right, you ready? Here. Put your feet up there. Ready? 1, 2, 3, go! All right, stay still. Don't move. Let Miss Smith get your distance.
All right.
All right. Okay, good job, bud. All right, guys, we're going to do this trial one more time at a wide angle so you can see both of us in the angle. So you should notice that the thing or the object with less mass, this guy, is going to move back at a much higher velocity. And the thing or person with more mass, me, I should move back at a much slower velocity because mass and velocity are inversely proportional. Remember, we're still going to have the same exact momentum, but his velocity should be higher since his mass is much lower. You ready? All right. 3, 2, 1. Good. All right, guys, welcome back to my classroom. So I just want to thank Rhett, my handy dandy volunteer, for helping me out there. And if you were watching, you noticed that Rhett moved a lot faster than I did. He had a lot higher velocity. And that's because Rhett, believe it or not, has a much smaller mass. Come here, Rhett. See, Rhett is this big and has a very small mass. As a matter of fact, he has a mass of 24.95 kilograms. Thank you, buddy. I am a little bit bigger. I have a mass of 92.97 kilograms. So I went back and watched the video and I did some calculations so we could figure out what Rhett's velocity was. So if you remember, velocity is distance or displacement divided by time. So I went back and figured out that Rhett moved 4.62 meters in 3.10 seconds. So whenever I put that in my calculator, that brought his velocity to 1.49 meters per second. And as I said, Rhett's mass is 24.95 kilograms. So to get momentum, remember momentum is mass times velocity. So I did Rhett's mass, 24.95 kilograms, times Rhett's velocity, which was 1.49 meters per second. And that gave me a momentum of 37.18 kilograms meters per second. So because of the law of conservation of mass, the momentum you start with has to be the momentum you finish with, the final momentum, I know that my momentum has to be equal but opposite of what Rhett's was. So mine should be negative 37.18 kilograms meters per second. It's the exact same momentum, but in the opposite direction. So here's what I want you to calculate. You know my momentum is going to be negative 37.18. So you're going to have to calculate my velocity, which is going to be negative because in the video, Rhett was moving to the right, which is the positive direction, so I was moving to the left, which was the negative direction. So I'm giving you my mass. So you have momentum, you have mass, and now you have to calculate velocity using your equation, P equals M, or mass, times V, velocity. So I want you to try to calculate that. All right, guys, if you have any questions, make sure you don't hesitate to email any of your teachers or post on Google Classroom if you guys use that. But we miss you guys, and we hope you're all doing well, and we look forward to seeing you again. Bye-bye.